Let's find a volume. Find the volume of the solid generated by revolving the region bounded above by y equals 2 cosine of x and below by y equals secant x on the interval between minus pi fourths and pi fourths, about the x-axis. I've already sketched the region here. I have my cosine function in blue and my secant function in what is supposed to be red, but it's not showing up very well on the camera right now, but I have my two functions graphed. And at minus pi fourths, if you think about evaluating them, the secant of pi fourths is root 2. The secant of minus pi fourths is also root 2. The cosine of pi fourths is root 2 over 2 times 2 is root 2. So they really do intersect at those 2 points right there. I guess all I really needed to know, though, is that I have a top function and a bottom function over that interval. So I'm thinking about the washer method, because I have a big radius up to the cosine and a small radius up to the secant. So let's see, I'd have the integral from minus pi fourths to pi fourths of pi, which I'm just going to go on right out front, of the big radius squared, so that'd be 4 cosine squared x, minus the little radius squared, secant squared x, with respect to x. I'm going to rewrite this in terms of 2 separate integrals. So in this first one, I've gone in and pulled that 4 out front. In the second one, I do need to remember there's a pi out front of it. Put this balance back on there. This second one's actually the easy one of the two because the antiderivative of secant squared is just tangent. And that'll be easy to evaluate here in just a moment, but I need to do a little bit of work on this one. Now, fortunately, I know a trigonometric identity that's going to help. I can use this formula for lowering powers, and this is the second one in this sequence of videos for this week where that identity, or one of these two identities, has come up as useful. So these are really nice to know, and we should probably know them at this point. So what I'm going to do is I'm going to take this integral and just do some scratch work on it. In fact, I think I'm just going to use an indefinite integral in my scratch work, find an antiderivative formula that I can just throw down on the previous board when I'm ready. So I have cosine squared x dx, but I can rewrite that as the integral of 1/2 1 plus cosine of 2x dx, just using that nice happy identity. The 1/2's just going to hang out front for a minute. And then I can find a nice, happy antiderivative formula here. I'd have 1/2 x, and now I need an antiderivative for cosine of 2x. Well, that would be 1/2 sine of 2x. And of course here, with the indefinite integral, I need a plus c. When I move this over to my other board, I won't need the plus c anymore because I'll be dealing with a definite integral. But there's the antiderivative formula I'm going to be using. Off camera, I'm just writing that down where it goes in the other problem. So not a very interesting part of the video right now, like I'm keeping a secret from you. But there is what we established on the previous board. I have 4 pi times all of this evaluate from minus pi fourths to pi fourths. So we're ready to evaluate now. And so if I just look at this last bit here, I'm going to rewrite it a little bit. I'm going to go on and say that 1/2 times 4 is 2. So that would tell me I really have a 2 pi hanging out front there of that x plus 1/2 sine of 2x. And then I still have a minus pi. Do that in 2 parts, excuse me. Evaluate that from minus pi fourths to pi fourths. And then I have that minus pi tangent. Evaluated from minus pi fourths to pi fourths. So all that's left to do now is to evaluate these 2 little bits and then to find our final answer. So let's see, I have 2 pi times, I need to plug that pi over 4 in, so I get pi over 4 plus, well, when I plug a pi over 4 in, that's going to become a pi over 2, so I'm just going to get a 1/2, minus what happens when I plug a minus pi fourths in, so minus pi fourths. And let's see, when I plug a minus pi fourths in, it's going to become a minus pi halves. I get a minus 1/2 there. Minus pi times the tangent of pi fourths is 1, minus the tangent of minus pi fourths is minus 1. All right, so let's see what all of this works out to be. Pi fourths plus pi fourths is pi halves. 1/2 plus 1/2 is 1. Let's see, minus 2 pi here. And then finally, I distribute this 2 pi through, and I get pi squared plus 2 pi minus that 2 pi, and finally all I have left is a pi squared. And that's my nice, happy final answer.